So I'm not going to go back as far as saying, well, in year 9, this is how we did it. I would have done that last year, and I would have said, oh, in year 10 we added this, and now in year 11 we're going to do that. What I want you to understand is the whys, all right, the why we do things now, so that you can actually start to use that why we do things to approach any level of problem. So when we are trying to solve, we're generally trying to find the answer for a letter. 9 times out of 10, it'll be X, all right? So we've got some sort of equation that in the real world would have some purpose to it, like finding Celsius if we know Fahrenheit, or finding Fahrenheit if we know Celsius. I mean, these days we just stick it in our phone, right, and say, what is 89 degrees Fahrenheit in Celsius? It's pretty cold, actually, but whatever. But there are formulas that are used, okay? So sometimes we're given one formula, we need to turn it around to another formula. In the exam, that's called rearranging, all right? So that's fine. What we need to be able to do is put a number into a given formula to find the result. That's called substitution. But sometimes we just want to know the general formula for what is X equal to, all right? And that is solving, okay? So we've got lots of operations. We've got adding, subtracting, multiplying, dividing, square roots, squares, and all of those things. We're going to leave squares and square roots out and just deal with those other 4 basic equations because we're calling this simple solving. All right? We've already done how to solve with squares. That's quadratics. We factorise. We find 2 answers where there are answers. We use the discriminant. We use the quadratic formula. We use our calculator, etc., etc. Of course, when we're doing simple solving, we can also use our calculator. The problem is that if you're using your calculator in the exam and not giving the working, you could end up only getting a correct answer, only you, whereas if you just showed the 6 lines of working, or it can be 8 lines of working or 2 lines of working, you might end up getting an R for a merit mark, okay? The skills involved in solving equations are also obviously the same skills we use when we're rearranging. The difference is that we haven't got numbers to simplify it. So instead of having 5 minus 2 is 3, we might have 5 minus t, which we can't do anything with. So we just have to leave it as 5 minus t and address the other issues around whatever we're trying to simplify. Okay? So I'm going to move up to about year 10 level. In year 10, you were given equations that looked something like this. Do you remember them? All right. And we said, what are we trying to do here? We're trying to isolate the x. So we want to put the x all on one side. And actually, it doesn't matter which side it is on. At any point when we're solving equations, because these 2 sides are equal, we can swap them over. So if we end up solving for x on this side, it doesn't matter. We can just at the end swap them over because they're equal. All right? So generally the rule for this type of problem is take away the smallest one from the biggest one. So we've got, all right, so that has gone to this side. When we are moving things across the equal sign, one of the big things we need to remember is they go last in the queue. All right? So last in the queue or bottom of the heap. An unweighted fraction. That's really important, that when we are moving it to the other side, they either go behind what's already there, or if we're dividing, they go underneath. So we've got 5x minus 2x. This one here is going to jump all the way out to here, negative 3 minus 4. It doesn't always matter, but sometimes it does. All right? So pretty easy. We get 3x equals negative 7, and then we're dividing to get rid of the 3. So sometimes it's easiest to do this, which hopefully you did in your graphs test, and then leave your answer as a fraction. Negative 7 over 3 is the perfect answer. If you write this as negative 2 1/3, that's also perfect, but you've now given yourself one set of working to make a mistake in, If you write it as negative 2.333 recurring with dots or whatever, that's also perfect, but negative 2.3 is not correct. With a 1 dp after it, it is kind of correct, but it's not the actual answer. And when we're finding it, we should actually be trying to find the exact answer and then find out from the question what sort of accuracy we might need. Okay? So those ones are pretty easy. In Year 10, we added in denominators into our pretty pictures. So we might have even added in fractions. So let's go to a Year 10 sort of yucky one. All right, something like that. Now we're into the complicated. What we're trying to do is isolate x. So we need to attack it one piece at a time. There are piles of ways of attacking this. We could get rid of the denominators first, which is what I like to do because then I only have one line of working. Or we could multiply out the brackets first. I'm going to leave that alone. What we need to remember is that what we are doing is the opposite function on the other side. And we're doing that to cancel it out. So by multiplying by 3 over here, what I'm actually doing is multiplying by 3 over here as well. So I'll get 3 over 3, which is 1, cancels it out. So that 3 that I multiplied over here to hold the balance equal. So multiply by 3, nothing's changed, still the same. Therefore, we can go with that. So this is called cross-multiplying. All right, we're going to multiply by the denominator on the other side if we only have a fraction here and a fraction here. If we had another fraction, we'd have to work out something else. So to get this, I'm going to get 10, 12, and then I'm going to multiply out the brackets. I could have done them up there and then multiplied, but then I would have had 2 lines here, so I like to have 1 line here. So multiplying it out, we've got 20x minus 10 equals 24 minus 48x. Now I need to get all the x's on one side. It doesn't matter which side. I'm going to take this negative and add it on this side because it sounds nicer. If I'd taken the 20 to this side, I would have had a negative. So I like positives. Remember to put it at the back, not at the front. Equals, the 24 was in the cube first. The 10 is joining the 24. We've got 68x equals 34. X equals 34 over 68. Yeah, we could leave it like that. But what does that equal to? Good, a half. 1 over 2. 34 goes into 68 2 times. All right, so we have to look at what we're doing and do it slowly. So that's what we're going to do today. Is